Hello everyone, welcome to Cracku DLR series. In this series, we are covering 100 plus CAT level DLR sets for CAT 2026, covering easy, moderate and hard difficulty levels. In this video, you will get one complete DLR set and the PDF will be mentioned in the pinned comment. Download it before you start. Pause the video, try solving the set by your own and continue to watch the video. If you're preparing for CAT 2026 and want a serious DLR practice, then this series is for you. And if you want more DLR sets, we have thousands of them. It's very simple, just go to Google and search Cracku DLR Sets.
In this question, it is given that there is a research firm which requires all its employees to scan their fingers to get the pass key. So the order in which they scan it the first time should be maintained every time they scan. Now, because people are forgetting this, the security firm is making some changes to what is allowed and what is not allowed, and we are required to solve the questions based on this information. In this question, it is mentioned that to allow for more variations, the lab has decided to allow a pass key if 2 out of the 5 fingers are out of place but 3 of them are in place. So for example, if the original sequence of entering was say TIMRL, if this was the original sequence, TLMRI is also allowed. So for example, TLMRI is allowed. This is allowed, but TMRLI is not allowed. Now if you notice, in the allowed version, T is in the right place, M is in the right place and R is in the right place. Only L and I are interchanged. So this is allowed where exactly 2 fingers are out of place. But in the case where it is not allowed, T is in the right place but M is in the wrong place, R is in the wrong place, L is in the wrong place and I is in the wrong place when you compare it to the original sequence. So here 4 fingers are out of place, so this is not allowed. Now we are required to find out how many different sequences of scans are allowed for any given person's original scan. So to solve this, let us assume that the original sequence is the same as what is given, that is TIMRL. Notice that it doesn't matter what the original sequence is, but we are using this just for understanding it better. Now, one case where none of the 5 fingers are out of place is allowed, where all the 5 fingers are in the proper sequence. So the number of ways in which this can be done is exactly 1, where the key entered is TIMRL. Now suppose we have exactly 1 finger which is wrong and 4 fingers which are correct. Now let us see the number of ways in which this is possible. So suppose the first 4 fingers are in place, then the 5th finger also has to be automatically in place, because if you have 4 fingers in place, there is only 1 finger remaining and 1 slot remaining, so even it has to go into the right place. So there will not be a case in which exactly 1 finger is out of place. So for 0, we have one way where there are 0 fingers out of place. When there is exactly 1 finger out of place, there are no cases possible because that is not allowed. Now let us look at the number of cases in which exactly 2 fingers are out of place. So again, let us draw 5 blanks, in which we will first select the number of ways in which we can select the keys which are in the right place. So the 3 fingers which are in the right place can be selected out of these 5 blanks in 5C3 ways. That is 5C3 is 10. So once you select the 3 fingers which are in the correct place, let us assume that they are the first 3 fingers. Now you have 2 fingers and you have 2 slots and you want both of them to be wrong. So for example, the key which was supposed to be in the 4th place now has to be in the 5th place, and the key which was supposed to be in the 5th place has to be in the 4th place. So once you select the 3 keys which have to be correct, there is only one way in which you can get it wrong. So the number of ways in which exactly 2 fingers will be out of place is 5C3, which is equal to 10. Now notice that we can allow for a maximum of 2 fingers to be out of place. So the total number of ways, the total number of different sequences of scans that are allowed for the original scan will be 1 plus 0 plus 10, which is equal to 11. So the correct answer is 11. Now let us go to the next question. Here a lab has allowed for different variations of the original sequence of 5 fingers, such that if each finger is misplaced by 1, even that is allowed. So for example, if the original sequence was TIMRL, then ITRML, this is allowed. if this is the original sequence. But L, I, M, R, T, this is not allowed. Now notice that in the sequence where it is allowed, I is varying by 1, T is varying by 1, M is varying by 1, R is varying by 1, and L is constant. Similarly, if you are looking at the sequence where it is not allowed and comparing it to the original, in this case I, M and R are all in the correct place, but L and T are varying by 4 because the first one is now 5th and the 5th one is now 1st. This is not allowed. Now we are required to find out how many different sequences are allowed for any given person's original scan. So again, let us assume that the original scan is TIMRL. The reason we are doing it is only for ease of understanding. Now again, let us assume that say 0 keys are misplaced. All the keys are perfectly in place. The number of ways in which you can do it is exactly 1. That is, once you know that the sequence is TIMRL, the number of ways in which you can go 0 wrong is again TIMRL. So that is one way. Now the number of ways in which exactly one pair of keys are interchanged will be, you can select the pairs which are interchanged in either 1, 2, 3 or 4 ways. So it can be either TI or IM or MR or RL. So there are 4 ways in which one pair of keys can be interchanged. Notice that the pairs which are being interchanged have to be consecutive. Now let us calculate the number of ways in which exactly 2 pairs of keys are interchanged. Now if you are assuming that TI is interchanged, the next one, the keys which can be interchanged are either MR or RL. So if TI is being interchanged, IM can again not be interchanged because then I would go into the first place and T would be in the second place. So if you are interchanging them again, T would go to the third place and that is not allowed. So if TI is interchanged, either MR can be interchanged or RL can be interchanged. Similarly, if TI is not being interchanged and if say IM is being interchanged, if IM is being interchanged, there is only one possibility, that is RL. So the number of ways in which exactly 2 pairs of keys will be interchanged is, here there are 2 and here there are 1. So 2 plus 1, which is equal to 3. So the total number of different sequences that are possible are 1 plus 4 plus 3, which is equal to 8. Now let us look at the next question. Now in this question, suppose the lab is allowing, instead of 5, it is allowing 6 fingers. That is, once you put in your 5 fingers, it is asking you to choose one more finger and even scan it once. So now you have 6 scans. Now the lab is allowing for the original sequence of 6 inputs, where at most 2 scans out of the 6 are out of place, as long as the finger which is originally scanned twice is the same and the other fingers are also scanned once. Now how many different sequences of scans are allowed for the original scan? Again, to discuss this, let us assume that the correct original sequence is say TIMTRL. Now let us figure out the number of ways in which exactly 0 fingers are out of place. This can be done exactly once. As usual, if this is the original sequence, you need the new sequence to be exactly the same as this. Now the number of ways in which one finger is out of place and 5 fingers are correctly in place again will be 0. Because if you have 5 fingers in place, the 6th finger has to be the little finger. There is no other way. So exactly 1 finger wrong and 5 fingers wrong, 5 fingers correct is also 0. Now let us figure out the number of ways in which 2 fingers are out of place and 4 fingers are in place. In this case, because we have a repetition of 1 finger twice, we will have to consider 3 separate cases. The 3 separate cases are, when we are discussing 2 fingers to be out of place, if the 2 fingers are both the thumbs, then we will first calculate the number of ways that is possible. If suppose it is 1 thumb and 1 other finger, then we will calculate the number of ways it is possible. And finally, if both the thumbs are in the correct place and the 2 fingers which are misplaced are 2 other fingers, we will calculate the number of ways possible. And then we will sum it up. Now suppose we have both the thumbs to be out of place. Now the number of ways in which this is possible, we will see. So what we are saying is, in the 6 fingers, the other 4 fingers are correctly in place, that is I, M, R and L. Now we are saying both the thumbs are out of place. This again is not possible, because even if you are interchanging both the thumb finger key, it will be the same, because both of them are exactly the same. So this possibility is 0. Now let us look at the case where one thumb is out of place and one of the other fingers are out of place. So again let us write down the 6 blanks. Now let us select the number of ways in which we can select which thumb is out of place. This can be done in 2 ways. Now say we are selecting for purpose of understanding that the first thumb is out of place and the fourth thumb is correctly in place. So here the fourth finger that is entered has to be the thumb which is correctly in place, and the first finger that is entered should not be thumb. Now the number of ways in which we can select which finger will be scanned first will be 4. That is, it can be either I or M or R or L. So the first blank can be filled in 4 ways. But once you select which finger is entered first, in that place thumb has to go. So for example, in this case, if you are selecting that, the first finger that has to be selected is, say, the middle finger. Now thumb has to go in the place where the middle finger was originally scanned, and all other places have to be the same as the original. That is, the second one has to be I, the fifth one has to be R, and the last one has to be L. Only in this case will there be exactly 2 fingers which are out of place. So the number of ways in which we can do this is 2, where we are selecting the number of which thumb is out of place, into 4, where we are selecting which of the other fingers are also going to be out of place. So the number of ways this is possible is 8. Now let us select the option where both the thumbs are correctly in place. So the first one has to be thumb T, and the fourth one also has to be thumb which is T. Now out of these remaining 4 fingers, 2 of them are exactly out of place and 2 of them are exactly in place. Now selecting which two fingers are out of place can be done in 4C 2 ways. Again, for ease of understanding, let us assume that we selected I and T to be out of place and R and L to be in place. So once we selected that R and L have to be in place, we'll fill them up. Now we know that I and T have to be out of place. The only way that is possible, again, because there are only 2 blanks left, is if they interchange their positions. So once we selected which 2 fingers have to be out of place, there is only one way in which we can fill them up. So this can be done in 4C 2 ways, which is 6. So the total number of ways in which the total different scans which are allowed will be 1, where there are no fingers out of place, plus 0, where there is exactly 1 finger out of place, plus again 0, where the 2 thumbs are out of place, plus 8, where there is 1 thumb and 1 other finger which is out of place, plus 6, where both the thumbs are in place and 2 other fingers are out of place. The total in this case is 15. Now let us look at the next question. Here it is said that again this lab is allowing for 6 scans, that is, 1 finger has to be scanned twice. But once you figure out which of the scans are, suppose the lab allows, but now the sequence is allowed if the fingers are misplaced by exactly 1, as long as the finger that is originally scanned twice is the same and the other fingers are also scanned once. So again let us assume that here it is given that the original sequence is L, R, L, T, I, M. Now what it is saying is that each of the fingers have to be misplaced by exactly 1 place. This is similar to the second question that we have solved, where each of the fingers can be misplaced by 1 place but not by more than 1 place. So let us again look at the number of ways, the number of different sequences in which this can be, the number of different sequences of scans which will be possible. Let us again do the usual thing, which is that suppose there are no pairs which are interchanged. This is the original key, original sequence, and the new sequence is the same as the original sequence. The number of ways this is possible is 1. Now suppose that there is 1 pair which is interchanged, exactly 1 pair. Now the number of ways in which we can select which pair is interchanged is 1, 2, 3, 4 and 5. So we can select the 1 pair which is interchanged and we'll keep all the other fingers the same. This can be done in 5 ways. Now if you are looking for exactly 2 pairs which are interchanged, let us see the number of ways in which this can be done. Now suppose the 2 pairs which are interchanged, suppose the first pair that is interchanged is, say, LR. So we are saying that we will consider the case where LR is interchanged. Now we need to pick one other pair which is interchanged. Now the next pair can be either LT or TI or IM. Now suppose LR is not interchanged, that is L is constant and the first pair which is interchanged is the second one, which is RL. Now the number of ways in which we can pick one other pair which can be interchanged is, it can be either TI or IM. Now again let us assume that the first two, that is LR, first two fingers are constant and the first pair which is interchanged is LT. Now we need to pick one other pair which is interchanged and there are only two fingers left, that is IM. So the number of ways in which we can get exactly two pairs to be interchanged is 3 plus 2 plus 1, which is 6. Now there is one more option possible, which is there are exactly three pairs which are interchanged. Now as there are 6 fingers, that is LR, LT and IM, the only way in which we can get exactly 3 pairs to interchange is if all of them are interchanged. That is LR is interchanged, LT is interchanged and IM is interchanged. So the number of ways this is possible is 1. So the total in this case is 1 plus 5 plus 6 plus 1. This is equal to 13. One of the things that I want to tell you is in these last few days in the run up to CAT, solving a lot of questions will be very useful to you. So we have created a lot of PDFs which include useful questions. You can download those PDF. You have to just Google search Cracku quant topic wise questions and you will get the PDFs and try to solve them on your own. Once you solve the question or once you struggle to solve the question, the link for the video solution is given in the PDF itself. These PDFs have been downloaded thousands of times in the last few weeks. I'm sure they'll be very useful to you. Download these PDFs and try to solve them. Again, just you have to Google search Cracku quant topic wise questions to get the PDFs.